Characteristics of acids and bases. This is part of a much larger high school chemistry unit on acids and bases. So let's first off start with a definition. Now there's more than just one definition for an acid or base, which might seem a little strange, but the only one that we're going to cover at this stage is the Arrhenius definition. Now, in acid-base chemistry, the Arrhenius definition limits what can be considered an acid or base, which is why there are other definitions. I'm not going to get into those others. You'll get into those others in higher level chemistry courses, but we're just going to stick to the Arrhenius definition. So an Arrhenius acid ionizes when placed in water to produce hydrogen ions or H plus ions. Like we discussed before, these H plus ions could also be considered H3O1 plus or hydronium ions. Now, an Arrhenius base ionizes in the presence of water to produce hydroxide ions. So, formulas of acids and bases. So, acids typically begin with a hydrogen. We see here we have HF, HCl, HBr, I won't say them all, H3PO4. There's several different acids that we could write here. This is just one list. Bases, on the other hand, typically end in OH. Now, here's where the little catch comes in. There are some other notable bases that do not end in OH, but still are considered bases by the Arrhenius definition. So now, how do these bases, calcium oxide, how are these considered bases? So let's just look at this. If calcium oxide is combined with water, do you remember what happens when a metal oxide combines with water? What is formed? Calcium hydroxide. Now, this calcium hydroxide is going to be in solution at this point. All right, so we've taken liquid water and we've taken solid calcium oxide and we've placed it in, we've combined them, and we've produced calcium hydroxide aqueous solution. So now, when we see this CaOH2 here, what exactly does that mean? Well, basically, just imagine you have this beaker. It's got some water in there, and you got calcium ions rolling around. Calcium ions rolling around. It's got a 2+ charge, and you got hydroxide ions rolling around. Billions and billions and billions and billions of them. All right? All on their own, separated from each other. Okay? Billions of them. What about NH3? When NH3 is placed in water or combined with water, we get, I won't get into what those arrows mean. That is a reversible, that is a two-sided arrow. I guess I will. It just means that the reaction can be reversed. We get NH3 plus H2O, and your products are going to be NH4, 1 plus, and what's left over? Hydroxide ions. So that formation of hydroxide ions in the presence of water means that NH3 is also considered a base. So let's talk about these other bases here, and we'll do the acid as well. So when I say that NaOH, when placed in water, produces hydroxide ions, that means that the Na1 plus and the OH1 minus break apart from each other. Now, again, these ions, they're in solution, so we're going to put the little AQ there, all right? First time using this, we had solid sodium hydroxide, all right? And so we get this, essentially we have this container with water in it, and again, we would have the Na1 plus hydroxide ions all throughout, randomly placed in this container of water, and again, billions and billions of them. Okay? So what about the acid? Let's take HCl. Let's place it in water. We're going to get H1 plus Cl1 minus. Again, they're aqueous. Okay? So they're in this container of water, billions and billions of them, existing as H plus ions and CO1 minus ions. For the sake of you guys, I won't spare you my continued drawings here. Okay? All right, let's talk about these other properties of acids and bases. 1, taste. Acids taste sour. Some common acids that you may have lying around the house: household vinegar, lemon juice, orange juice, citrus fruit acids, vitamin C, soda. So household vinegar or acetic acid, there's a few different kinds. You can see down here, we got cider vinegar, you got, I can't even tell, white vinegar, cider vinegar. These are the only ones I have. I'm really not sure what these others are. But acetic acid, we use vinegar in a lot of different recipes. One of my favorite, I just have to mention, is in a Eastern style barbecue sauce. Now you might be thinking, Eastern style, what does that mean? East, the part of the world? No. Eastern part of the U.S. Eastern part of North Carolina, which is where I'm from. In the eastern part of the state, vinegar sauce that we use, the barbecue sauce that we use when we have pig pickings, yes, that's what I said, is made out of vinegar. It is a vinegar sauce, leaves a nice tart taste into your mouth as you're eating the pig. And off on the side note of this, when we say barbecue in North Carolina, we mean that we're having pig, not that we're grilling outdoors. If I'm grilling a hamburger outdoors, what do I say? I'm grilling a hamburger outdoors. But barbecue, pig. Sorry. Side note. My kids miss all this through this COVID stuff, so I just I think I said. I just figured I'd insert some fun times here too. So vitamin C is used as a vitamin supplement. So it's ascorbic acid. Phosphoric acid can be found in soda. Now you're not going to taste the phosphoric acid as being sour because there's so much more sugar there than there is phosphoric acid, but it indeed does have phosphoric acid in it. And an interesting story about that, I used to have some little bitty cans of soda I was a closet Duke basketball fan back in the day, and I had these cans of Duke Blue soda when they won the championships, and I believe 91 and 92 or sometime in there. And over time, the ascorbic acid started to eat through the metal, a reaction between an acid and a metal, which we'll talk about later, and actually just ruined the can. Soda leaked out, made a big mess of all the other Duke stuff I had stored in there. Bases are going to be bitter. So household bases that you're going to have lying around, perhaps in your medical, in your cabinet of medicines, milk of magnesia and Maalox, both of which are used to calm stomach acid. That is a reaction between an acid and a base, a neutralization reaction, which we've talked about before. And baking soda. Baking soda has lots of different types of uses. And I didn't put on here what baking soda is, but it is sodium bicarbonate. So it is in fact a base as well. So I forgot to mention, do not go tasting things just to see if they're an acid or a base. That's not what I want you to do. These are just some common things that you may have tasted before. Do not go tasting things. It can hurt you. So, acids, concentrated acids and concentrated bases can cause skin burns, which is why we should always wear gloves, an apron, and goggles when we handle acids or bases. One unique property of bases is that they often can feel slimy or slippery. Now, yes, this is exactly like soap. Now, soap is interesting because soap is made by the combination of a particular base with a particular acid, which gives it that soapy feel. Bases that come in contact with your skin could burn you, but allow you to know that they're there because you do get this slimy sort of sensation that feels very much like soap. So indicators. There's lots of different kinds of indicators for chemical reactions. We're just going to talk about two: litmus paper and phenolphthalein. So litmus paper turns acids red. You can see down here in this picture, this is an example of litmus paper, that on the lower end of the pH scale we have the red, and bases turn litmus paper blue, so on the higher end you have the blue. It is a blue there, it's like a dark navy blue. You can see over here in the picture on the left, we have some things that are green or even maybe yellow, which show that it's more neutral or closer to neutral, and then you see the reds and something closer to a blue up there. Now, phenolphthalein turns acids clear and turns bases pink. Now, another term for bases is alkali. We're not going to get into the specifics on why alkali is also a term, but just know that it is a term that you could also see. You'll learn about it later. Reactions between acids and bases, or of acids and bases. Well, the first one, between acids and bases, is our neutralization reaction, which is covered in chemical reactions. It is a type of double replacement reaction, where we have an acid coming together with a base, and these are solutions, and it forms water and a salt. Now, remember, in chemistry class, a salt means any ionic compound that is not a base. The second reaction we have here, we have a metal replacing hydrogen here in this acid, and this will produce hydrogen gas, kicks up hydrogen all by itself in the form of hydrogen gas. This is what happens when certain metals react with acids. And when we have a reaction of an acid with a carbonate or a bicarbonate, here's our sulfuric acid, here's our carbonate, we're going to get the production of carbon dioxide as one of the products, always. Other examples of acids or bases, and these are definitely things that you do not want to go tasting. Obviously, the carbonated water you could taste, but do not go tasting these other things. These are other examples that you may have in your house or somewhere that have acids or bases in them. Car batteries have sulfuric acid. It's a very, very strong acid. In fact, I'll tell you a story about that. I learned the hard way that car batteries have acids in them. And then when I was a kid working at my family's auto shop, and I was carrying an old battery, and it sloshed out some of the solution, and I didn't even know that it was acidic and on me until a couple hours later, not even like 30 minutes later, I looked down and there's holes all over my shirt. I had to change shirts. Luckily, nothing got on me. Stomach acid is hydrochloric acid. Carbonated water is considered carbonic acid. It's not a very strong acid, but it is still considered an acid. Drain cleaners and oven cleaners have sodium hydroxide in them. Glass cleaners often have an ammonia solution. And bleach is sodium hypochlorite, which we won't get into the specifics about how sodium hypochlorite is a base, but it is in fact a base. Electrolytic properties. So just to discuss what electrolytes are, in case you do not know, an electrolyte is a substance that when dissolved in water produces ions that can conduct an electric current. Now, in order to determine if a substance has ions in it, we can take an apparatus such as this right here. It has a bulb. We plug this into an outlet, and these two prongs right here go into the solution. Now, if this solution contains ions, then it's going to create a pathway for that electricity to flow, lighting up the light bulb. If it is a non-electrolyte, you place it in there, nothing happens. Nothing happens. All right. So this is just a conductivity apparatus to allow us to test if something is an acid or a base. Now, to get more technical, we have non-electrolytes, strong electrolytes, and weak electrolytes. A non-electrolyte, such as ethanol, isn't going to produce ions, therefore does not light up the bulb at all. A strong electrolyte does produce ions, and only ions, and will in fact light up the bulb very brightly. A weak electrolyte has some ions, but also has some particles that aren't ions, the original particle that dissolved. The example here is acetic acid. And it'll light up the bulb, but not very brightly, because there's just not as many ions there to conduct that electric current. So, point being, acids and bases are both electrolytic, or both have electrolytic properties. Sorry, I'm watching my kid go down the hill in his little car that some might call dangerous, but he's safe. He's got a helmet on. Both conduct electric currents. Sometimes we have, with acids, we could have strong or weak, and same thing with bases. They could be strong or weak. So this concludes my presentation on the characteristics of acids and bases. I hope that it was funny for you. I made a couple blunders there. But it is what it is. Have a great day. Stay safe and wash your hands.